Okay, Madison, for number 6, we're supposed to find the value of x in this diagram here. So what we know when we look at this diagram, we know that the interior angles of a triangle add up to what? Yes, 180. And if we know that on this triangle here, we know one angle, right? How can we figure out what this angle here equals? Well, we know that angle is a vertical angle with this angle, right? So what would the measure of that angle be? Well, since this angle here is a vertical angle with this angle, then vertical angles are congruent, okay? And since vertical angles are congruent, then we know this one equals 50 also. All right, so then we know that 180 minus 55 minus 50 will give us x. Does that make sense? Okay, good. So Natalie, number 7 and 12, let me pull those up, okay? Well, that didn't work. Let me try again. Technical difficulties or user error, I don't know. But let's see if this works. Okay. So starting out with number 7, we're supposed to use the diagram and find the values of both x and y, okay? So when we look over here, sometimes when you have to show 2 variables, it's a little more difficult. You have to kind of look at other relationships. So first, let's see if we can figure out x. So when we look here, we know this is a right angle. So we know this side is also going to be a right angle, right? I'm going to erase that just because it'll make it easier to see that. So since we know both of those are right angles, we would know that 15x plus y equals 90. Let's see. In the problem, it tells us that DEFG is congruent to WXFG. So if they are congruent, then we know that corresponding parts are also congruent. So that will tell us that this side is congruent with this side, okay? So we can say 3x minus 5 equals 10, right? Yeah, Natalie, that's right. Sorry, I was on the other screen. So 3x minus 5 does equal 10, and then you can solve for x that way. And the reason that you know that is because it tells you that those two shapes are congruent, and you know corresponding parts of congruent shapes are congruent. No, x doesn't equal 15 because you're going to have to add 5 to the other side. So you get 3x equals 15, and then you have to divide by 3. So you get x equals 5. And then do you see how to use that information to plug back in and solve for y? Yes, that's right, Natalie. All right, and number 12. Okay, so for 12, we have to write a proof. You know what? It may be easier for me to do this. There's not going to be enough room to write on there. I'm trying, guys. Okay, so here is number 12. We're given that triangle ABC is isosceles with base AC and that BD bisects angle B. Okay, so if we look at our picture there, what do we know when it says BD bisects angle B? What can we tell from that? Yeah, it cuts angle B in half. So we would have, first you're going to state your given, right? Always state your given. And then next we would be able to say that ABD is congruent to CBD. okay? Because of the definition of an angle bisector. And then what can we use this part of the given to show? If it's an isosceles triangle, what does that tell us? Well, it doesn't tell us that D bisects AC because it's telling us that the whole big triangle is isosceles. So if it has the base AC, yeah, then we know AB is congruent to BC. So that would be another step we could write down. AB is congruent to BC. And that would be the definition of an isosceles triangle. And then the next thing, when we look at this picture, we have two triangles, two of the two smaller triangles, right? They share a side. So what do we know about that side? That it's also congruent. And why is BD congruent to BD? Because of the reflexive property, that's right. So now we've shown a side, an angle, and another side. Now, is the angle the one that's included between those two sides? Yes. So side, angle, side would be how you can prove that those are congruent. Okay. Okay, so I worked number 12 just a few minutes ago with Natalie. The first step of a proof is always what? Yeah, so you're going to state your given. So you'll say that ABC is an isosceles triangle with base AC, and that BD bisects angle B, and that those two are given. Then what do we know from the fact that ABC is an isosceles triangle with base AC? What does that show us? Well, we know that AC is the base, but when you look at the definition of an isosceles triangle, what do we know about that triangle? Yeah, that your two sides are congruent. So we'll know that AB and BC are congruent. Okay. And that would be because of the definition of an isosceles triangle. Now, it also tells us that BD bisects angle B. So what does that tell us about that angle? Okay, so it separates them into two equal angles? Yes? Okay. So then we can say that ABD, angle ABD, is congruent to angle CBD because of the definition of an angle bisector, right? And then what do we know when we have a triangle or when we have a picture of two triangles like this, where they share the same side? This side here, BD, what do we know about that side? When you have two triangles that share a side, like BD, okay, in this picture, what do we know about that side that's shared between the two of them? Yeah, we would be able to say that BD is congruent to BD because of what property? Nope. When something is itself, what's that reason? Something is equal to itself. Yeah, that's the reflexive property. So you'll say BD is congruent to BD because of the reflexive property. And then have we shown enough information to say that the triangles are congruent? We have a side, an angle, and then we showed that side is congruent as well. So is that enough information? Okay, yeah, so that's enough to say that triangle ABD is congruent to triangle CBD because of side, angle, side. And it's side, angle, side because the angle is included between those two sides. Does that make sense, Ethan? Okay, so for number 13, what is the third congruence needed to prove that triangle PQR is congruent to triangle STU using the indicated theorem? So if we look down here, we're looking at triangle PQR, which is this triangle, and triangle STU, which I kind of cut that off, goes this way, okay? And we're doing, for A, we're doing hypotenuse leg. So what is the information that you need to know to prove two triangles are congruent by hypotenuse leg? You need to know that they both have 90-degree angles. You need to know that their hypotenuse, that their hypotenuse and their legs are congruent, okay? So it's marked that they both have the 90-degree angles here and here. And it's also marked that the hypotenuses are congruent, right? So we just need to show that one of the legs is congruent with another leg. So you could say that QP is congruent here to TS down here, or that QR is congruent to TU, that these long sides are congruent here. Does that make sense, Ethan? Okay, so for B, you're proving angle, angle, side. So what it gives you in the picture is an angle here. Oh, sorry, I'm on eraser. So it gives you an angle here and then an angle here, right? So that's one angle. It does not give us another angle, but it does give us a side here and here, right? So we need to show the other angle. So the other two angles is either going to be that angle P and angle S are congruent, or that angle R and angle U are congruent, okay, for it to be angle, angle, side. Does that make sense too? Okay, good. Lily, you had a question on number 1 on the chapter test. So if you are looking at a triangle, Lily, and all of the sides are congruent, like in number 1, and then you need to classify it based on the angles, the measure of those angles, right? Well, what do we know about the interior angles of a triangle? What do they add up to? all three angles inside of a triangle add up to 180, right? Okay, so if they all add up to 180, and we know that in an equilateral triangle, all of the angles are also equal, then what are we going to do, or what can we do to figure out the measure of those angles? Well, we know that it is an equilateral triangle, but we need to classify it also based on the angles. Equilateral is based on the sides. I'm trying to pull up the picture of it, but it's not. The computer is not being very nice today. Yeah, none of them would be 90 degrees, so it would be acute. Or you could also say that it's equiangular, because we know that an equilateral triangle has all three angles that are equal to. Does that one make sense? Okay, good. Sorry, it's still not letting me pull up any of the pictures on that one. All right, Charlotte Ann, number 7. So the key on number 7, I worked it earlier, is that in the diagram, so the words for number 7 say, in the diagram, DEFG is congruent to WXFG. So if you know that those two shapes are congruent, then do we also know that the corresponding parts of those shapes are congruent? So since we can tell that, are you able to look at it and see how to solve for x now? No, Charlotte Ann. It's not going to be 15x plus y equals 3x minus 5. 15x plus y is the measure of the angle there. I know that's kind of hard to see because it's long. So hold on just a second. I think I may be getting this to work finally. All right, so you see here that, I know it's kind of small, but we have, since it tells us that these two shapes are congruent, then we know that this side and this side here are congruent, right? So we could say 3x minus 5 equals 10, and then solve for x. Do you see that, Charlotte Ann? Yeah, then plug x back in and just solve for y. And you know, so what are you going to set 15x minus y equal to? Or maybe that's plus y and I just wrote it on top of it. Yeah, 15x plus y equals what? It doesn't equal 180. It's the same measure as this angle here. Okay. So if this one's 90, then the other one is 90 also. Does that make sense? Okay, good. So Lily, you asked for 4 through 6, would they all be set equal to 180 degrees? So 4, yes, that would be set equal to 180. You would say this plus this plus this equals 180. On 5, you would say this plus that 90-degree angle equals 180. Now, 6 is a little bit different because you don't have this other angle here, but how can we tell what that other angle would equal? No, it's not a right angle. What types of angles are these two angles here? Yeah, they're vertical angles. And what do we know about vertical angles? Yes, vertical angles are congruent. So if we know that those two are vertical angles, then we're going to be able to tell that this angle is also equal to 50 degrees, right? So then we could say 180 minus 55 minus 50 equals x. Okay? Does that make sense? So whenever we have angles that, or when we have two triangles like this, that their points touch, okay, they create these vertical angles, right? Because the sides of those angles form opposite rays, which means this side goes off in this direction and this side goes off in this direction. Same thing here. This side goes off in this direction and this side goes off in this direction. So when those sides form an X like that, and you have these two angles across from each other, those are vertical angles. And we know that vertical angles are congruent. That's one of our theorems from back in chapter 2. So if this angle is 50 degrees, then that means this angle here is also 50 degrees. And then we know the interior angles of the triangle all add up to 180. So we would say 180 minus 50 gives us 130, right? And then minus 55 gives us x. Okay. Does that make better sense? Okay, the right angle on that second triangle, it's just kind of extra information, because we're not trying to find anything, the measure of anything in this triangle. Sometimes they just give you extra information that you don't need to know to try to throw you off. And that's what happened here. Because it doesn't really tell us anything that would relate to this triangle here. Yes, ma'am. So Devin, I've done number 12 a couple of times. Let me see. I'll try and see if I can pull it back up. Okay, so for number 12, we're given that triangle ABC is an isosceles triangle with the base AC, and that BD bisects angle B. So what's the first thing we're going to do for our proof? Yes, so we're going to write these two things and say that they're given. So now let's look at that given information and see what that shows us, okay? So for triangle ABC, since we know it's an isosceles triangle and that the base is AC, what does that tell us? What else can we tell about that triangle? If we go back into 4.8, Devin, what do we know about isosceles triangles? What's the definition of an isosceles triangle? No, Lily, an isosceles triangle does not have three congruent sides. That's an equilateral triangle. Yeah, so an isosceles triangle does have two congruent sides, two sides that are the same and one that is not. So if we know that AC is the base, the two sides are going to be congruent. So that will tell us that AB and BC are congruent, okay? And that will be because of the definition of an isosceles triangle. Now, if we look at this part here that says BD bisects angle B, what do we know about that? What does that tell us? No, it doesn't tell us that that's a right angle because it's talking about angle B, which is the angle up at the top, up here. So if we know that BD bisects it, what's the definition of bisect? So it cuts it in half. So if we know that BD bisects angle B, then we know that this angle and this angle are congruent. So ABD is congruent to CBD because of the definition of an angle bisector. And then what else do we know when we have two triangles that share a side, like this side here at BD? What do we know about BD? Well, we do know that BD bisects angle B, but when we're looking at the two triangles there, Devin, let's see. Let me make the picture a little more clear. So we have this triangle here, and then we also have another triangle here. They share the side here at BD. So what do we know about that side? We know that that side is itself, right? It's the same thing. And when something is itself, what do we call that? What property do we call that? Here, let me ask you about this up here. What about this side here that's shared between those triangles? Yeah, it's the reflexive property. So it's congruent to itself because of the reflexive property. So we would say BD is congruent to BD because of the reflexive property. Now, when we look at these triangles, we've shown that AB and BC are congruent. We've shown that this angle here and this angle here are congruent. And then we've also shown that this side is congruent with itself. So we've shown a side, an angle, and a side, right? And that is the angle that's included between those two sides, correct? So we have proven that those two triangles are congruent to each other by side, angle, side. Does that make sense? Okay, good. You're welcome, Devin. Charlotte Ann, I saw you pop back in. Did you have a question? Oh, no, never mind. She left. Number 8, Ethan. Let me see. Okay, I'm trying to pull it up, so give me a minute. Okay, Ethan, can you see that picture there from number 11? Okay, so what number 8 asks us is to use the diagram from number 11 and then describe the transformation that you could use to move triangle MNP onto PQM. Okay, so if we look at that, now to take this triangle here, oh, sorry, I'm not on the right screen to draw. To take this triangle here and move it down onto the other position here. Are we going to be able to just reflect that? Could that be a reflection? My first thought, Ethan, looking at that, is that it could be a reflection. But since this one is not like on a coordinate grid where you could say it's reflected across the line y equals x or across the x-axis or anything like that, let's look at the other ways that we know we can move things around and see if it's one of those. Okay, this is just my thought process, how I would work through it. Okay, so we're not really going to be able to say if it's reflection because of that. So now, what are the other two ways that we know we can move things? Yeah, we know we can rotate and we can translate, right? So if we think about this, a translation maintains the same orientation of the picture. It just shifts it up or down, left or right. So if we move that top triangle up or down, left or right, is that going to flip it upside down like it is? No. So what we're going to have to do is we are going to have to rotate it. So now picture if we rotated it, 90 degrees would take it straight up, right? A 90-degree rotation would flip it this direction. And then another 180, or sorry, another 90 would flip it around to this direction here. So we could say that that would be a 180-degree rotation around, and then we would say that that would have to be around the midpoint of the line MP. So if we flip it totally here on that point, then it would flip back to make this triangle on the bottom. Does that make sense? Okay, good. I know those types are sometimes very difficult to visualize. All right, does anyone else have any questions? If not, I'm going to sign off and I'm going to go stand in line to vote. Oh, Lily, the answer for that one would be it's a rotation, a 180-degree rotation around or at the point, let's see, the midpoint of MP. So a 180-degree rotation about the midpoint of MP. Correct, Ethan. It would not be a reflection. So Lily, I did number 7 a couple of times also. Do you think you could just go back and watch the video, and I'll post the link on Google or on the lesson plans here in just a second? Okay. If you need more explanation of it, email me and let me know, and I can try to explain more. But it is worked out. I talked about it a couple of times on the video, okay?